Hi, hello, good morning, all of you. Welcome to my channel, Maths at the Rate VLN. అందరికీ ఉగాది శుభాకాంక్షలు. Today I am going to explain the topic relations from class 12 mathematics. The topic is relations. What is a relation? A relation is a subset of Cartesian product of A and B sets. So, what is the actual definition? A relation from set A to set B is a subset of the Cartesian product A cross B. And also we will write if A comma B is an ordered pair, A comma B belongs to relation R, capital R, then A is related to B. We will write A is related to B. Generally, we can represent in the arrow diagram, it is set A and this is set B. From set A to B is a relation. Set A to B is a relation. A, B, C are in set A, 1, 2 in set B. So, in Cartesian product, how many possible order pairs we have? A comma 1, A comma 2, B comma 1, B comma 2, C comma 1, C comma 2. These are the possible ordered pairs in the Cartesian product. In this, any one subset we called as a relation from A to B. From A to B. For example, if you take, let set A is 1, 2, 3, set B is 4, 5. A cross B, possible order pairs in A cross B, 1, 4, 1, 5, 2, 4, 2, 5, 3, 4, 3, 5. Any subset of A cross B is a relation. For example, 1, 4, if I write, it is belongs to relation. And now, how many possible relations for this? Means number of possible subsets for A cross B. How many possible subsets for A cross B? We can use 2 power n for number of subsets formula. Number of subsets. Number of subsets 2 power n. What is n? Number of elements in A cross B. So here 1, 2, 3, 4, 5, 6. So 2 power 6 possible relations we have. In that, we will take 1, 4 belongs to R. It means 1 related to R. 1 related to 4. 1 related to 4. We can also write like this. Now, coming to types of relations. What are the types of relations we have? What is empty relation, universal relation, identity relation, and inverse relation? What is an empty relation? We know already empty set is a subset to every set. Empty set is a subset to every set. In similarly, so the empty relation, there is no element in that relation. That relation we called as empty relation. Empty relation pi. Pi belongs to the relation. So this relation we called as empty relation. No element in the ordered pairs. And what is universal relation? So the set itself we called as a subset to itself. So then If all the order pairs in A cross B, if you consider that type of relations we called as universal relation. For example, here, if you consider that all these 6 order pairs, it is a relation, it is belongs to relation, then this type of relation we called as universal relation. All elements in that A cross B is a relation, involved in the relation, then we called it is universal relation. And what is identity relation? What is identity relation? If you get same value A comma A belongs to that relation, A comma A belongs to that relation, this type of relations we called as identity relation, and it cannot allow other elements. For example, 1 comma 1, 2 comma 2 belongs to that relation, then we called it is identity relation. For example, 1 comma 2 is there uh, in that relation, 1 comma 2 is there, 1 comma 1, 2 comma 2. So it is a relation, but it is not identity relation. Why? Because additionally we have 1 comma 2, the another ordered pair is there involved in this. That is the reason it is not identity relation. If you want to say it is identity relation, strictly it has to satisfy this condition A comma A belongs to R. It cannot allow any other order pairs in that particular relation. And now inverse relation. What is inverse relation? What is inverse relation? For example, if you take a relation R from A to B, R from A to B, the elements in the set R A comma B belongs to R, where A belongs to A, B belongs to B. This is the order pair for this relation, right? Now inverse relation means R inverse B comma A. So the domain becomes range, range becomes domain. B comma A belongs to that relation where A belongs to A, B belongs to B only. So B comma A we called as a inverse relation. Okay, next very important topic. Mainly you have to remember the reflexive relation, symmetric relation and transitive relation, and all these three together we called as equivalence relations. This 4 is very important, and try to remember each and every definition. For every question whenever you attempt, you have to write the definition of reflexive relation, symmetric relation and transitive relation. If any relation is satisfies all these three relations, then we called it is a equivalence relation. Very important. Even JEE main level question also they are going to ask based on this concept. Very important, and try to concentrate on these three relations. Okay, now first one, reflexive relation. What is a reflexive relation? A relation R on set A is reflexive if A comma A belongs to R for every A belongs to A. For every A belongs to A. The relation from A to A. The relation from A to A. In that, each and every element of this order pair, it should be like this. A comma A belongs to R. For every A belongs to A. A belongs to A. This type of relations we called as reflexive relation. So try to explain one example here. What is a reflexive relation? So the reflexive relation 1 comma 1, 2 comma 2, 3 comma 3 is a reflexive relation on the set A equal to 1, 2, 3. In set A 1, 2, 3, the relation from A to A, so in that it is included 1 comma 1, 2 comma 2, 3 comma 3, then only we called it is reflexive. Otherwise it is not reflexive. For example, if I write the relation 1 comma 1, 2 comma 2, is it reflexive relation for that set A 1, 2, 3? So it is not a reflexive. Why? Because the third element 3 is there, for that there is no order pair 3 comma 3 in this, so therefore it is not reflexive. Therefore it is not a reflexive relation. Next, symmetric relation. What is symmetric relation? If a relation R is symmetric, if A comma B belongs to R, implies B comma A is also belongs to R. The definitions are very simple. In reflexive relation, if you want to say a relation is reflexive, A comma A belongs to R, where A belongs to capital A. In symmetric relation, a relation R is symmetric if A comma B belongs to R, implies B comma A also belongs to R. For example, if you take 1 comma 2 belongs to R, that implies 2 comma 1 is also belongs to that relation, then only we will call it is symmetric relation. The given relation is in symmetric, otherwise it is not symmetric. You can consider an example for that. The relation R 1 comma 1, 2 comma 2, 2 comma 3, is it symmetric relation? You have to check. So in that set A, we have the elements 1, 2, 3, right? Here 2 comma 3 is there, but 3 comma 2 is not there. Here 3 comma 2 is not there. 2 comma 3 is there, but 3 comma 2 is not there. Does not belongs to that relation. So it is not symmetric. It is not a symmetric. Like that, you have to analyze the question and try to answer, and moreover you need to check whether it is reflexive or symmetric or transitive. Now we are moving to transitive relation. What is transitive relation? A transitive relation, if you want to say it is a transitive relation, if A comma B belongs to R and B comma C belongs to R, then A comma C is also belongs to R. Means if you take one example here, 1 comma 2 belongs to R, 2 comma 3 belongs to R, then compulsory 1 comma 3 is also belongs to R, then only we called it is a transitive relation. Otherwise it is not transitive. Otherwise It is not transitive relation. Right? Transitive is very important, and if you fail to prove it is not transitive, then only we call it is a transitive. Transitive, it is in the transitive relation only. Try to remember in this what is the main point. If you fail to prove it is not transitive, then also we called it is a transitive relation. And equivalence relation. What is equivalence relation? A relation that is reflexive, symmetric and transitive is called a equivalence relation. Very important topic it is. Equivalence class. For A belongs to A, the set of all elements related to A is called equivalence class of A. Now the representation of relations, we know order pace or arrow diagram, matrix representation and graphical representation. And now try to practice some questions. Check whether the relation are they given 1 comma 1, 2 comma 2, 3 comma 3. Is it on the set A 1, 2, 3 is reflexive? See, all the elements are there. No? 1 comma 1 belongs to R, 2 comma 2 belongs to R, 3 comma 3 belongs to R. So then it is reflexive. Then it is reflexive only. Moreover, you can try to say it is symmetric. Is this relation is symmetric? So 1 comma 1 is there. If you interchange 1 comma 1 only, so then we called it is a symmetric relation also, and transitive relation also, and we called it is a equivalence relation. Next question, symmetric relation. Is it symmetric or not? You check. 1 comma 2 is there. 1 comma 2 belongs to R. Then 2 comma 1 is also belongs to R. Then it is symmetric. 3 comma 3. So it is symmetric relation only. Next. Thank you all. Completed today's class based on relations. So based on this concept, you can solve all the problems in NCERT textbook first. You will get the answers. If you need any topic, okay, any problem, you just comment on comment session. Then I will do the classes based on your requests also. And thank you all.